A direct drive gripper designed by Ellipse synthesis across two output modes. The gripper presented in this work can operate in two modes, namely the sense mode, which can sense and grip delicate objects like the Pringle chips, and the grip mode, which can exert high gripping forces. Forces at the fingertip can be estimated using actuator torques through the Jacobian matrix. Although this method is inaccurate, it is simple, keeps the sensing remote, and requires no new components. Gripping and sensing capabilities require conflicting force transmission properties for the gripper, which we achieve by choosing different Jacobian matrices for the same end effector point by switching output modes. Each gripper finger is manipulated by a 5-bar mechanism with PLDC actuators at A0 and B0 and the end effector point P as the fingertip. The dimensions of this 5-bar mechanism are determined through optimal synthesis by shaping the velocity ellipses across two output modes. This optimization problem was solved using IP-opt with multiple initial guesses computed to satisfy the kinematic constraints and be free of input singularities. The sense mode was designed to have velocity ellipses with major axis oriented nearly horizontally to achieve high sensitivity in the horizontal direction. The grip mode was designed to have velocity ellipses with major axis oriented nearly vertically to produce high forces in the horizontal direction. Using this 5-bar, a gripper is fabricated and tested for its sensing and gripping capabilities. In the sensing experiment, contact between the fingertip and a wooden block attached to a brass rod is detected using actuator torque feedback. Contact is detected when the feedback torque exceeds a threshold value. The deflection of the brass rod before detecting contact was significantly low for the sense mode compared to the grip mode. Conducting the same experiment for different lengths of the brass rod showed that the sense mode could detect contacts for stiffnesses as low as 9 Newton per meter, while the grip mode could not detect contacts for stiffnesses less than 90 Newton per meter. To show the gripping capability of the grip mode, the maximum load the gripper can hold without slipping is found by pulling the wooden block upwards using the UTM. Conducting the same experiment for the sense mode showed that the gripper in the sense mode could only hold up to 225 grams of load. In conclusion, a gripper with two fingers using the 5-bar mechanism was designed by shaping velocity ellipses across two output modes. The gripper was fabricated and experiments were conducted to show its capabilities. The sense mode could sense fingertip forces 3 times smaller than grip mode. The grip mode could exert forces 4 times greater than the sense mode.